In 7.2, we look at permutations, and there's a little bit of a definition up here. Permutation is an ordered arrangement of items that occurs when no item is used more than once and the order of the arrangement makes a difference. So you'll see problems in this section referring to, like this one is the order that their appearances are. Maybe someone gets first, second, and third place. Arranging books on a shelf, because obviously you couldn't use a book more than once when you put them on a shelf. So look for things like that, where you can't use the item more than once, or you're putting them in an order, and the order makes a difference. So number 1 says 6 performers are to present their comedy acts on a weekend evening at a comedy club. How many different ways are there to schedule their appearances? So if you had, and we're going to look at it kind of like the license plate problems before, 6 different slots for them to appear in. The first slot, there's 6 different options. And then once a person has been placed into the first slot, then we only have 5 remaining. And then 4 after that, and then 3, 2, and then 1. So we're going to multiply 6 times 5 times 4 times 3 times 2 times 1, which is 720. So we actually used there our counting principle from before that said the number of events for the first, number of outcomes for the first event, outcomes for the second, third, fourth, fifth, and sixth. And then you'll start looking at, once you've read the section, we have a new notation where it's a factorial notation. In factorial, we're going to start with the first digit, or the first number 29, and then we're going to go down. But a quick way to do that, when I'm looking at this 29 factorial, would actually be 29 times 28 times 27 times 26 times 25, and I could keep going, but you notice that in the denominator I have a 25 factorial. So 25 factorial, in the denominator we would list out 25, 24, 23, 22, and so on. Then in the numerator, if I go ahead and stop at the 25 factorial, I won't have to continue on. We know that these are going to cancel out, so there's no reason to keep writing that. And then in your calculator, multiply the remaining 4 numbers, you would get 570,024. Okay, we're going to do the same thing with 2b without using the calculator's factorial key. Then we would have the 104 times 103. Notice the denominator is 102 factorial, so we'll stop there. And then the 102 factorials would cancel out. Now just multiply the 2 numbers together to get 10,712. Okay. 3a, we're going to start using, there's a permutation formula. It's a notation and a formula. So the notation we have is permutation. If we take n items and select r of them, so we're going to select a few out of a big group, then the way that we would put that in our formula would be n factorial over n minus r factorial. So this problem, 3a, says a club with 10 members is to choose 3 officers. So I'm selecting 3 out of the 10. President, vice president, secretary, so that does give them an order, and they can't be used more than once. So if each office is to be held by one person, no one can hold it more than one office. How many ways can they be filled? So that would be, out of 10 people, we're selecting 3. So my formula would look like 10 factorial over, we use the same n that we just used, 10 minus r, which is a 3, factorial. So what we have is 10 factorial over 10 minus 3 is 7 factorial, and then from the skill that we just learned, that would be 10 times 9 times 8 times 7 factorial. Cancel out the 7 factorial, and 10 times 9 times 8 is 720. So there would be 720 different ways that we could select a president, vice president, secretary out of those 10 members. Okay, 3B, for a segment in a radio show, a disc jockey can play 7 records. If there are 13 to select from, how many ways can the program for this segment be arranged? And we'll just use each one once, so it fits the definition of a permutation. Where we have 13 to choose from, we're going to select 7, and they're in an order. So we would have 13 factorial over 13 minus 7 factorial, which is 13 factorial over 6 factorial. So 13 times 12, 11, 10, 9, 8, 7, 6 factorial. We'll cancel with the denominator. Multiply using your calculator, and you'll get 8,648,640 different ways that 7 songs could be selected. Okay. And then in number 4, we're going to omit. It deals with duplicate letters, and so we're not going to do that one.